Welcome back, everybody. Let's go over one more time how to find out what the charge is on the ion of a specific element. So you can see from the last one that we did that the magnesium example is still up here. Magnesium's got 2 valence electrons. It loses those electrons and it becomes positively charged. Mg2 plus is its charge. We want to do another one now, and we're going to try and do one that gains electrons this time. Oxygen, its atom, we're going to look up how many electrons it actually has. So you'll want to look to your periodic chart, find it in group 16. Did you find it? Great. It's right there at the top. It's easy to find. Its atomic number is 8, so that means it has 8 protons and 8 total electrons. But to find out how many valence electrons it is, you could quickly draw that model, or you could find the pattern. Remember, it's in group 16, so it has 6 valence electrons. We'll go over that again just to help you remind you about that later. So it's got 8 electrons total. We're going to draw all of those. So yours, if you drew that Bohr model, would look something like this. Remember, it's got 8 and 8. Those would equal out to be 0, and atoms have a 0 charge. But what if it's going to form an ion? Remember, it forms an ion to get an octet, to get a full outer shell, and that makes it more stable. And so oxygen is very reactive as well. It only needs 2 more valence electrons to get to that stability that those noble gases have. Remember, all the noble gases have 8 valence electrons. They are all stable and they're all not reactive. So if we were going to draw the ion for oxygen, we would want this exact same setup on the ion side. Plus, we would know that it needs to get to 8, it could lose those 6, or it could gain 2 electrons. And so we're going to draw it on this side with it gaining 2 electrons. We'll put 2 extra electrons in that second orbital. I'll give you a minute to catch up as I pause. So as you begin to fill it in, you'll want to remember that the first level holds 2. The second level can hold a total of 8, just like the noble gases have. But remember, oxygen as an atom only has 6, and it would need to gain 2 more electrons in its valence shell to get that stability that it's looking for, to get that octet, which happens to be the most stable arrangement of electrons. And so let's take a look at the numbers now. The original atom had 8 protons, so it had 8 positive charges. It also had 8 electrons, so it had 8 negative charges, and that balanced out because atoms have no charge. But now it gained 2, so it has a total of 10 electrons now. So the positives and the negatives don't balance out. So if we were going to abbreviate the ion that we just created here on this side, we would put capital O, and it's got more negative charge. How much more negative does it have? It's got 2 more negative. And so O2 negative is the abbreviation that we use when we're representing oxygen's ion. Now, we can draw those out every time, but it gets a little bit tedious. And so I'm going to show you a pattern for figuring out charges on the periodic chart so you don't have to do that drawing every time to figure out the charge of an ion.